So we're done with the first chapter, right? That is units and measurements. So remember, no, tomorrow. Remember that there is an assessment tomorrow. Yeah. So prepare for it.
Yes, sir.
Yeah. So today we'll get started with this Forgot. But it is needed for your. If it is deleted, you cannot do practicals. So it's for your benefit only. I've explained. I told you the reason of why I'm explaining also. So first disclaimer I would like to give you: don't trust your deleted questions. They are deleted randomly. They may not be tested, but there are certain points which you cannot touch. You will be the loser at the end. Another, I'm trying to explain it again. You are a deleted question. If we teach it here, ensure you are studying it because there will be a reason why we are doing it. And the next year it might be important because I've seen 12 students struggling on the deleted question. So please take my suggestion. Marandra, there is nothing like deleted questions. If it is genuinely deleted and the topic is not important, we also will tell you. If it's not important, not important. That has no connection with any other chapter. So yeah. So today we will get started with basic mathematics, or I can call it as basic mathematical physics also. So it's not connected. Those are online, are you able to hear me?
Yes, sir.
Yeah. So in basic mathematics, I'm going to explain you about the different tools that are required. So the different tools that are required to solve problems. So when I say tools, they mean the mathematical tools. Okay. So first, we are going to discuss three important concepts. One is called as slope. Second is called as differentiation. And the third is called as integration. So these are the three important tools which you will be using in physics to derive certain mathematical expression at the same time to apply to solve certain problems. Okay. One minute. Okay. Yes. So the concept of differentiation and integration falls under a mathematical branch called as calculus. Okay. So slope is, I would say slope is basic extension of your coordinate geometry. So in today's class, we'll be mostly discussing only about slope and differentiation. That itself will take the time that we have in our hand. Okay. So first, let's start with the concept of slope. So what does basically a slope mean? If I have to look at something in a basic English, okay. If I take, there is a horizontal surface which is fixed. Okay. Now, what do I say about this horizontal slope? Can I say that the surface is flat? Right? And what can I say about the inclination it is making with the horizontal? So, what are the inclination with horizontal? What is it going to be? So, what is the inclination it is making the horizontal? Answer is 0 degrees. It is is completely level. So flat surface means I can call it as a level surface. Can I? Right. Then what do you mean by the slope? So slope is something where you have an elevation at one of the ends. So let's try to visualize it. So you go to these malls and all, right? When you go to these malls, you have a parking lot. What you have? You have a parking lot. Whether it is a bike or a car. Generally for these malls and all, where are the parking lots? Are they exactly, suppose there is a mall, okay. Where will the parking lot be? Will it be in the same level as that of the mall, or do you need to go down or up to do something like that? Most of the time you try to go down, especially if you take the screenings and all. First thing is they'll divert you to the downward path. Are you able to visualize? So actually what was happening, the place where they are building, they will take your number, right? Have you ever observed? Your parents will tell the phone number and they make a note of all the. So the place where the phone numbers are noted, I can call it as a level surface because your car is moving in this way, right? As soon as you start entering the parking pathway, you go like this. So from a level surface, you started going in this way. Means when you see it from the side, horizontal surface will start taking a bend. Is that right? So this is what you call it as flat surface. And this can be called as a ramp, or more technically you will call it as slope. Is that right? Now this is the side angle of the road I'm trying to talk about. To this side angle, if I add a little bit of mathematical details, can I say that if I draw an imaginary horizontal surface, means once you get down, you're not going to continuously get down. Once you get down, again you'll start traveling horizontally. Will you do that or not? Again, maybe you'll have another level, then you'll go like this. Again, you'll start traveling horizontally for some distance. So when you're doing this, with respect to this horizontal surface, if I say that this ramp is making an angle theta, are you able to understand? Are you able to visualize it first of all? So if I say that it is making an angle theta, then tan of this angle theta that this ramp is making with the horizontal is what is called as slope according to mathematics. So the ramp or slope, which I told you, is basic English. But if I have to observe the mathematical details in it, what am I supposed to do? I need to take the tan of the angle that elevation is making with respect to the horizontal. Okay, where theta is what? Theta is always the angle made with the horizontal. Is that clear? No, I'm first write it. Right. So theta is angle made with the horizontal. Now what I can do is, if I take the same concept to a two-dimensional geometry. Now what I'm going to do is, this ramp is basically a line segment. So I'm trying to connect the general terms to mathematical terms. So if I take this line segment, then if I start virtually extending on both the sides, it becomes a line. So if I have 2 points on a graph sheet, so joining those 2 points, what I can do is I can always think of drawing the line. 1 minute. Sorry, 1 minute. Yes, I can draw a line like this. Then this line is making an angle theta with the horizontal. The horizontal is basically x-axis. Right. Here, an important point to be noted is when you are measuring the angles. In your 9th grade, you would have had a chapter called lines and angles. Right. What does basically an angle mean? Sorry. Yeah. So, what is angle? It only raise. It can be anything, right? So, basically, if I take this as a ray, if I take this as a ray, and if I take another line as a ray, if I take them to be in this way, then both the lines, or I can say both the rays, let's say they are like this. Now, what can I say is the angle between them? See, it means they are actually coinciding. So, if I keep one of the rays fixed and I start rotating the other ray, then can I say that the second ray, if I take this as 1 and this as 2, can I say that the second ray is making an angle theta with the horizontal? Or can I say the angle between the first and the second ray is theta, for example? So angle is basically obtained through what kind of a process? What are the steps you need to follow? What did I do to the line? I kept the starting points fixed and I rotated one of the lines with respect to another fixed line. So angle basically tells you about the extent of rotation you are making, where the rotation you are making for one line with respect to another. Are you able to understand what I'm trying to say? Right? So then this is called theta. So angles are basically measured in two directions. One is anti-clockwise and the second is clockwise. Is that clear? So one angle is made in the anti-clockwise direction and the other is made in the clockwise. So anti-clockwise direction is considered to be positive and clockwise directions are considered to be negative. So anti-clockwise are considered to be positive and clockwise are considered to be negative. So this is what is a mathematical proof. right? So when you are able to, in mathematics, when you are able to write tan of the angle made by line with x-axis in positive direction. So what do we mean by positive direction? We call it as anti-clockwise direction. So if you take the angle here, then tangent of the angle made by the line is what is called as slope. So I want you to write down the definition. In mathematics, slope means tan of the angle. You just should not write tan theta. Tan of the angle made by the line with whom? With the x-axis in the positive direction. When I say with the x-axis, it can be with positive x-axis or negative x-axis. The line could have been like this also. Observe. The line could have been like this also. If I take this to be theta, it is still considered to be positive because it is making an angle in the anti-clockwise direction with the x-axis. So it is not, when I say positive, it is not positive x-axis. With the x-axis in positive direction, that is in the anti-clockwise direction. So that tan theta is what is called as slope, and it is represented by the symbol M. You learn about this in detail in your math under a chapter named straight lines. Is that clear? So Ron, are they sleeping? So, having said this, if I take the line like this, okay, if I take the line like this, I am considering 2 points, x1, y1 and x2, y2. Okay. So if I drop a perpendicular from here and a perpendicular from here as well, okay, then this distance will be how much? It is x1. And how much is this distance? Y1. Then how much is this distance? X2. And how much is this distance? Y2. How much is this angle? Theta. Right. If I drop a perpendicular from here, then can I say A, B, C? Right. So can I take it in this way? One minute, I have to close the door. Right. Now this angle will be theta, correct? So this will be theta. Now what is AC? How much is this distance? Correct. X2 minus X1. So can I write this as X2 minus X1? And how much will BC be? Y2 minus Y1. Then what is tan theta from this? Y2 minus Y1 divided by X2 minus X1, or you will call it as difference in Y coordinates divided by the difference in the X coordinate. And this is the formula for slope. And remember, slope is defined only for a straight line. This is what is called as slope of a line. So slope is basically defined only for a straight line. Have this in your mind. And this is a very, very, very important expression. You can ask me why did I teach it here? You will understand it slowly. Remember this. Next time when I ask you slope, what does it mean? It is the difference in y, ratio of difference in y coordinates to the difference in x coordinate. Is it clear? Right. This is the slope of a line. Slope. Let's consider line passing through 1, 2 and 3, 4. Find the slope of the line. Do it fast. You can do it in 30 seconds. Passing through the points 1, 2 and 3, 4. Those are the 2 points. So what is slope? y2 minus y1 divided by x2 minus x1. So y2 minus y1 is what? 4 minus 2. x2 minus x1 is 3 minus 1. Answer will be 2 divided by 2, which is going to be 1. Okay, is it clear? Right. Suppose let's see if you are able to understand. If I give you a velocity time graph, right? Slowly from math, I'm shifting to physics. So in math, you take y-axis and x-axis. In physics, you take one parameter, the dependent parameter on the y-axis and the independent parameter on the x-axis. But before that, have you started learning functions? You know what is a function at least from your school? In math, yeah. You know what is a function? Nothing. Okay, that's fine. You know this thing, right? P of x is equal to 2x square plus 3x plus 1. If I ask you what is P of 1, what will you say? 2 into 1 plus 3 into 1 plus 1. 2 plus 3 plus 1, which is going to be 6. Okay. So what is this basically? From your 9th standard knowledge, I mean. It's basically a polynomial. And what does the x represent? X represents that there is a polynomial with the variable x. So if I ask you P of 1, what did you say? So you got the value of this as 6, right? For example, if I take P of x is equal to 2x plus 3. Okay. What kind of a polynomial is this? This is a linear polynomial. So from your basic knowledge of 10th standard, tell me, what does a linear equation represent? It's basically a straight line. So instead of p of x, can I write it as y? Can I write y is equal to 2x plus 3? Means if you write p of x is equal to 2x plus 3, it represents a polynomial. If I replace p of x with y, it represents a linear equation in two variables. So linear equation in two variables, what does it represent? It basically represents a straight line like this on a graph sheet, right? So how to get that straight line? You'll do something like this. Now you'll put x is equal to 1, you will get y value. So when you put x is equal to 1, what do you get the value of y as? 5. What does this represent? 1, 5. It is basically the Cartesian product. Cartesian. It's basically the coordinate of the point which is on the graph sheet. So you can take it as 1, 5. Is that right? Are you able to understand? So 1, 5 is one of the points on the line. Likewise, I'll have multiple points. So this 1 represents x coordinate and 5 represents the y coordinate. So basically, whatever is related to x-axis is called as independent variable. X-axis is called as independent variable, and y is called as dependent variable. Why do we call it as independent? Because in the place of x, we are free to substitute. I chose x is equal to 1 so that y came out to be 5. I didn't choose y to be 5 so that x is 1. Is that right? So basically, our hand will go in such a way that whatever is there on the left-hand side is generally treated as dependent variable, and whatever is the expression, whatever the variable in the expression on the right-hand side will be treated as independent variable. So x is independent and y is dependent. That is a basic rule. That is like you see when I say velocity time graph, right? Which one depends on the other? Velocity depends on time or the time depends on velocity? Velocity depends on time. That is why time is taken on x-axis and velocity is taken on y-axis. Is that clear? So if suppose an object is moving with a uniform acceleration, then the graph will look something like this. You'll be learning about this. Okay. Now, if I take this point to be 0, u, and if I take this point to be t, u plus 18, then what is the slope of this line? U plus 80 minus u divided by t minus 0. U and u will get cancelled. So you will get 80 divided by t, which is equal to a. Right? So slope of what? If you find the slope of a velocity time graph, what do you get? You get acceleration. Are you able to understand? So this is how you relate physics and math. Similarly, if I give you displacement time graph, if I ask you slope, right, even without giving you a graph, if I ask you slope, by default, what will you write? Change in the y coordinate divided by the change in the x coordinate. So here y coordinate is displacement, x coordinate is time. So what is the rate of change of displacement according to you? Velocity. So slope of a displacement time graph represents velocity. Is that clear? So this is how it keeps going. Done? Now, having this knowledge, we will go to the next part, that is differentiation. So if I have to explain differentiation, right, I need to just touch the basics of what are functions. Okay. I'll not take much of your time because I'll explain from whatever you know. If I write p of x is equal to 2x plus 3, this is what? A polynomial, a linear polynomial. So if I replace p of x with y, then y is equal to x plus 3 becomes a linear equation in two variables. you can also call this as linear polynomial, and you can add a suffix called function. Basically, if I have to give the simplest definition of function, since you don't have knowledge of what is relations and all those things, I have to give you a simple definition of what is function. It is a mathematical expression where you give an input. I repeat, where you give an input, it gives you only one output. So if you want, you can write it down. You can write down the basic definition of function. This is for your understanding. Functions are mathematical expressions where one input will generate a unique output. Where you multiply one input, you get a unique output. Okay. So depending on what kind of a function you're dealing with, it is given a name. For example, if I call it as p of x is equal to 2x square plus 3, what is this? This is a quadratic polynomial, right? So what you can say, if I replace this with y is equal to x square plus 3, I can call it as a quadratic function also. Are you able to understand? Similarly, you have y is equal to sine theta. If I replace theta with x, if I write y is equal to sine x, I can call this as a trigonometric function. So basically, like how you write something as p of x, where p stands for the name of the polynomial and x stands for the variable. Okay. In different, when you write a function, you can always write a function as y is equal to f of x, and you read it as y is a function of x. So here f stands for function and x stands for the independent variable, and y stands for the dependent variable. Is that point clear? It's called independent variable and it is called dependent variable. Those who are online, are you able to hear? Are you with?
Yes,
Yes.
sir.
Is it clear, guys? Right?
Yes, sir.
Take x and so then I can think of drawing a random shape like this, where I'll call this as y is equal to f of x. Some function. You're not worried whether it is a quadratic function, polynomial function, whatever it is, I'm not concerned about it. But I'm saying the graph follows the condition y is equal to f of x. Is it clear? So to this graph, can I think of drawing a line like this? It's my wish. To the graph, within it, I will draw I'll draw a line which cuts the curve. Okay, I'll draw a line which cuts the curve at 2 points. Okay, so I'm calling it as a line. So basically, what is a line which cuts the curve at 2 points called as? Then what is a chord? Yes. So secant is basically a line that cuts the curve at more than 1 point. Is that point clear? Now see, from here, if I drop a perpendicular, then I can say this point is x comma 0. It is x, okay? Now, from here, I will drop a point and I will write this as x plus h comma 0, where this distance is called as h. Can I do that? Can I do it? Are you able to understand? If I take this to be the x-axis, if I take a point 1 comma 0 here, I'll write 2 comma 0, or I will write it as 1 plus 1 comma 0, my wish. Why did I write it as 1 plus 1? Because the first number is 1. For example, I had 3 comma 0. How will I write it? I can write it as 2 plus 1 or 1 plus 2. Which one will I choose? I'll choose to write it as 1 plus 2 comma 0, so that this 1 tells me that I'm taking that first 1 comma 0 to be the starting point, and from that 1 comma 0, my point 3 comma 0 is at a distance of 2 units. So similarly, if I take it as h units, from the point h, what is the other? Where is the other point? At a distance of x plus h, because from the origin, this is x. Does it make sense? Are you able to understand what I'm saying? Okay. So if I take a point on the curve, then what will this point be? It will be x comma. I will take this x and substitute it in the place of x inside f. So what will happen? It will become x comma f of x. Then what will this point be? Tell me. X plus h comma f of is that point here. Now, if I ask you, what is slope of AB? Can you tell me? What is slope of AB? It is f of x plus h minus f of x, the whole divided by h. How did I write it? y2 minus y1 divided by x2 minus x1. X plus h minus x is how much? H. That is why I directly wrote it like this. So this is slope of AB, or I can call it as the slope of secant. Can I call it as slope of secant? Yes. Now comes another important point. So first make a note of this. This is slightly complicated concept for you, but you're learning something new. We are touching functions, we are touching slope, too many mathematical concepts, but focus. This is slope of secant. Right. Now listen, observe this. X, Y. If I take the curve like this, then I take the tangent, slope, secant here. Right? Now observe what is going to happen when I move the secant slightly downward. What is happening? So observe, this point is A, and if I call this point as B, now when I move this secant slightly down, then I can say this point is A dash and this point is B dash. Then I'll move it slightly down. Then this is A double dash, B double dash. Then I'll move it even more down. When I do it in this way, what is actually happening to the distance between A and B? It is reducing, right? So when I keep moving it down, there will be one particular instance where the distance between A and B, when you try to zoom in and see, right, the distance between A and B will be so small that the secant which you are trying to draw will become a tangent at a point. Accept it. Now, breathe. So it becomes a tangent at a particular point. When can that become a tangent? When the distance between A and B is decreasing, or when the distance between A and B is decreasing, can I say that the foot of the perpendiculars are also coming closer to each other? Can I say that if the foot of perpendiculars are coming close to each other, what is happening to H? It is almost getting to 0. Means both the foot of the perpendiculars will actually start coinciding with each other. Accepted? When that kind of a scenario occurs, see, what did I say is the slope of the secant? It is f of x plus h minus f of x divided by h. Now, to this, if I write something like this, see this word you need not worry about it. Limit, you call LIM stands for limit. If I say limit h tends to 0, so how do I read it? Limit h, what did I say? Tends to 0. It is not equal to 0, okay? Tends to 0 means the distance between those 2 points is very, very, very small that it can be approximated to 0. So limit tends to 0. If I write something like this, then this will become slope of not a secant anymore. It will become slope of tangent. And the slope of tangent is what is written as dy divided by dx. And this is what you technically call it as differentiation of y with respect to x. Is that point clear? So now you can ask the reverse question. When you differentiate anything with respect to a variable, what is that you are actually getting? What are you getting actually? Differentiation of y with respect to a, go in the reverse. When you differentiate something with respect to a variable, you are actually getting the slope of a tangent to any curve at a particular point. Now you are able to connect both the slopes. So what did I tell you in the beginning itself? Slope is defined only for a straight line. But here what did I do? For a curve, we try to find the slope. So if someone asks you what is the slope of a curve cannot have a slope. Curve can have a slope only if you draw a tangent at that point. So only a tangent to the curve at that point will have a slope. So are you able to understand what I'm saying? So whenever someone asks you what is differentiation of y, differentiation of something with respect to another, why do we differentiate? You have to say to find the slope of the tangent to the curve at a given point. Is that clear? Right? So why do we differentiate? To find the slope of the tangent to a curve at a given point. So now what I'm going to do is I'll give you a table where the table contains the function and its derivative. So derivative is the output obtained by differentiation. Derivative is what? Output obtained on differentiation. So what is the function here? If I say y is equal to x power n, what is dy by dx? X power n minus 1. So derivative of x power n is nx power n minus 1. Actually, this one formula is sufficient for you to solve anything in physics as of now. In physics, you use only 3 formulae. The next is about sin x. So y is equal to sin x. Dy by dx is, any idea? Yes, cos x. Similarly, y is equal to cos x. What is dy by dx? So these 3 formulae are sufficient for you to solve any problem. Is it clear? No. If you have y as f of x plus g of x, so if you have y as a sum of 2 other functions or difference of 2 other functions, plus or minus, then dy by dx. So I'm writing something in the denominator, right? X. So y, which I'm writing in the numerator, is dependent variable. The x that I'm writing in the denominator is a dependent variable. So always remember, differentiation is done for a dependent variable with respect to an independent variable. For example, if I give you y is equal to sin x, what is dy by dt? You know, most of you write it as cos x. Because what is that you missed to check? What are you differentiating with? You're differentiating with time. Is there any time here? So that is why you remember only dy by dx is cos x, but dy by dt is not cos x. This is wrong and this is right. This is clear. So always when you're differentiating, the first question that you need to ask is you're differentiating with respect to which function? Which function are the one in the denominator? So dy by dx is equal to, you can write it as d by dx of f of x plus or minus d by dx of g of x. It's not a rocket science. I'll take an example and explain it. You'll understand it. For example, if I have y is equal to x square, then what is dy by dx? First formula, x power n. So 2x power 2 minus 1. So this will be 2x. So here I wanted to mention an important point. N should not be equal to minus 1. Wait. It's not like n is equal to minus 1 is differential. It can be. Yeah. Integration n cannot, because x power minus 1 is derivative. Minus 1 by x square is a derivative. You can do it. It's integration you cannot do it because you will have log x. So dy by dx is equal to 2x. Is that clear? Right? So I gave you something now. Y is equal to, for example, if I have x square plus sin x, then y is what? Y is f of x plus g of x. Then what will dy by dx be? D by dx of f of x plus d by dx of g of x. Means, what is derivative of x square? 2x. Derivative of sin x? So, if you have a function y is equal to x square plus sin x, then dy by dx is given as 2x plus cos x. Similarly, if you had minus, what will you get? y is equal to x square minus sin x, what would have been the answer? Dy by dx would be 2x minus cos x. Correct. Is it right? No need. You have to see what is the variable. Y is a function of some other function. You understand it slowly after you learn function. What is your doubt? F of x plus or minus? Plus or minus, you can, whether you do f of x plus g of x or you do f of x minus g of x, you do the same thing. For example, in this problem, I did f of x plus g of x. Here I did f of x minus g of x. But what is the operation I'm going? See, operation is plus or minus. Means if you're doing a plus here, you do a plus here. If you do a minus here, you'll do a minus here. That's the thing. Is it clear? Yeah. Now listen to this. If y is a product of two other functions, y is equal to f of x into g of x, what will you get? You know this, sir? What is it? So dy by dx will be equal to f of x into d by dx of g of x plus g of x into d by dx of f of x. Okay. First, I'll take an example and explain, then you can copy it. For example, the same x square sin x is there. Okay. Then you can write y is equal to, you write the first function as it is, x square into, you will differentiate the second function. Then you will put a plus. Then you will write the second function as it is and you will differentiate the first function. Okay. So you will have x square cos x plus 2x sin x. And this kind of a rule is called as product rule. That is product of two functions. Have learned this or not? You have learned it now. So this is called as product rule, and y is equal to x square cos x plus 2x sin x. In some books, they refer it as UV rule also. I'm not sure what name you have heard. Did you hear UV rule? So where
Yes.
u is one function and v is another function. You can either call it as UV rule or product rule. Okay. Shall I move on? Shall I proceed? The last but one rule is something like this. If I have y is equal to f of x divided by g of x, where g of x is not equal to 0. Okay. Then dy by dx is equal to, observe this is slightly complicated, a big formula. It will be equal to g of x, that is denominator, into d by dx of numerator minus numerator into d by dx of denominator, the whole divided by denominator square. Okay. So how does it work? Denominator into derivative of numerator minus numerator into derivative of denominator, the whole divided by g of x, denominator square. dr stands for denominator, nr stands for numerator. Is it clear? If you have y is equal to, I'm taking the two functions only. Y is equal to x square divided by sin x, where sin x is not equal to 0. Then what is dy by dx? Tell me. Denominator, that is sin x into d by dx of x square minus numerator into d by dx of sin x, the whole divided by sin x the whole square. So this will give you what value? Derivative of x square is 2x. So we'll have 2x into sin x minus x square into cos x divided by sin square x. So this is what is dy by dx. If you want, you can simplify and write it. That's like this: 2x into sin x by sin square x. What will you get? Minus x square into cos x divided by sin square x. So what I can do here is, one sin x can get cancelled. So I'll have 2x cosecant x minus x square into, here I can write the sin square x as sin x into sin x. What is this value? Cot x into cosecant x. That's it. Is that point clear? So this is what is dy by dx. And what is the name of this rule? Then you call it as quotient rule or u by v rule. Is it clear? And the last thing that you need to know is called as chain rule. Okay, the last one is called as chain rule. Y is equal to f of g of x. You would have not seen this. You have learned it. Okay. So there is something called as chain rule, which is f of g of x. So don't get confused between product rule and this thing. In product rule, you have f of x into g of x. What is happening here is, there is a function within another function. Okay, this is called composition of functions. Okay, so where you have one function within an other function. For example, if I have y is equal to sin x, okay, I'll y is equal to sin x, or I'll write like this: f of x is equal to sin x, and g of x I have it as, let's say, x square. Then what is f of g of x? So f of x is sine of, in the place of x, what are you replacing with? That's right. In the place of x, you are replacing it with g of x. But what is g of x? X square. So this will become sin x square. If at all I want to write g of f of x, then what will this give you? G is x square. So in the place of x, I need to replace with sin x. So sin x square. Or this is also equal to sin square x. One common mistake I have seen is sin x square. Some of them will write it as sin x square. No, it is sin square x, because sin x is multiplied with sin x. Are you able to understand that f of g of x and g of f of x, they both are not same? So f of g of x is sin x square. Means, for example, if you have sin 30 degree, f of g of x will become sin 900. Other than x square, 900. right? Whereas if you have g of f of x, it will become sine square of 30. So sine 900 is not the same as sine square 30 degrees. Are you able to understand? Yes. So when you have these kind of functions, they are called as composition because you write one function within another function. So for my satisfaction, I want to give you a question and you tell me. F of x is equal to cos x and g of x is equal to sin x. Okay, I want you to find what is f of g of x and I want you to find what is g of f of x. So what is f of g of x? So cos of sin x. What is g of f of x? Very good. So this is what we call as composition of functions. Does it make sense? So when you have composition of functions, what you need to do is you need to write dy by dx as, you will first differentiate f of g of x into, you will differentiate g of x. So what will you do? You will first differentiate. So write it in a single step, okay? If you have copied this part, I'll erase it. Can I rub this part? So I'll write it in a single step into d by dx of g of x. Can I do this? Yes. Now listen. You wrote two functions, no? Y is equal to sine x square. For example, if you have sine x square, see this rule you will not apply much in your initial chapters. At the end, you will apply it. Okay, by the time you will slowly get grip over differentiation. But since I have to explain this, I'm doing it. So if I have y is equal to sine x square, then what are you supposed to do? First, you are able to understand, see if it is only sine x, it is a single function. But in the place of x, you have anything other than x, x square, x cube, 2x, 3x, whatever it is. If it is not, the coefficient of x is not 1 and the power of x is not 1, it is some other function. Okay. So whenever you face that kind of a scenario, you need to understand that you need to use chain rule. So y is equal to sine x implies dy by dx is equal to, derivative of sine is what? Derivative of sine is cos, that's it. So cos of, you should not write x. You will write x square as it is. So that is the meaning of d by dx of f of g of x. Means derivative of sine is cos, right? Cos of what? Whatever is the angle, write the same angle. Into differentiate the angle now, x square. So what will the answer be? 2x cos x square. Now this is the answer. Is this clear? Are you able to understand? Can I give another question? Will you try? This one, 2. If I have y is equal to sine of cos x, then what is dy by dx? So first, look at the function, sine of cos x. So in the place, so what should have been for it to be a normal function? It should have been sine x. But in the place of x, what do you have? Cos x. So it is a composition of function, means function within a function. So I need to go with chain rule. So how do I start with? First is derivative of sine is what? Cos. So cos of, what should I write inside? Whatever is here, blindly write it. Into d by dx of the one which is inside, that is cos x. So what will you get? Minus sin x into cos of cos x. So this will be the answer. Is that point clear? Solve this. Answer. So first take that minus outside. So derivative of cos is minus sign of sin x into d by dx of sin x, that is cos x. So minus sign of sin x into cos x. Clearly put the dot, okay, or else you will get confused. Is that clear? So you'll not use this much, but one more point I'll ask. Y is equal to, if I have sin 2x, what will you do? Derivative of sin cos 2x into derivative of 2x, which is 2. So you will have 2 cos 2x. Is it clear? Okay. Since we have time, I'll explain integration also. It's simple only. So I'm not going to get into much details of integration, like how I did for slope and derivatives. I'll just tell you what is integration. Integration is basically called as anti-derivative. In the sense, it is exactly the reverse process of differentiation. Okay. Now, if I have x-axis and y-axis, x is called as the independent axis and the y is called as the dependent axis. So suppose I have a function y is equal to f of x like this. Okay, it is my wish. It can be like any function. Depending on the real function, we'll draw the respective graphs. If I drop a perpendicular here and I call this point to be a comma 0, and if I drop a perpendicular here and I call this point to be b comma 0, okay, then what I can do is I can do two kinds of integration. One is called as indefinite and the second is called as definite. So when I say indefinite integrations are done without limits. So you don't apply any limits to it. Whereas definite, as the name suggests, definite means you're sure of where you're trying to talk about. Okay. So definite means with proper limits. In your physics, mostly you'll use only definite integration. Is it clear? Now, please draw it. Okay. Suppose I have y is equal to f of x. Okay. Now, if I differentiate this with respect to x, I'll get some other function. So I'll call that some other function as capital F of x. Are you able to understand the difference? For example, y is equal to sin x is there. What is dy by dx? Cos x, no. The sin x is what I'm calling it as small f of x, and this cos x is what I'm calling it as capital F of x. Like this, what I'm trying to say is when you differentiate a function, you will get another function only. You will not get something else. So on differentiating a function, you get a function. So I'm saying when you differentiate small x, let's say you're getting capital F of x. Now what I can do is, can I write dy is equal to capital F of x into dx? Can I do this? Now what I will do is, I will integrate on both sides. When I do this, I can write integral of dy is equal to integral of f of x into dx. Is it clear till this step? Okay. I told you one point. Integrals and derivatives are counter operations of each other. So they get cancelled. If that is the case, integral of d of y, it is actually like this. So this symbol is called integral. It is basically an elongated S. So you write an S, you pull it in this way, it look like that. Okay. So it's an elongated S where this integral and derivative, they get cancelled. If it is only d of something, then integral and derivative can get cancelled. Whereas this side, on the right hand side, I cannot do this. Just 2 minutes. Listen. So on the right hand side, I cannot do this. That is wrong. Because what is there in between? You have a function. Like I told you one important point, right? When I told you about differentiation, you need to ask with which variable you're differentiating. Similarly, integration also you should ask with which variable you're integrating. So how do you rate this is integral of f of x with respect to x. WRT stands for with respect. So this is how you read it. Is that clear? So what is going to happen here is, if I have y is equal to sin x, for example, then what is dy by dx? Cos x. No? So from here I can write dy is equal to cos x into dx. So if I integrate on both the sides, integral of this thing. So integral of dy is y is equal to integral of cos x dx. But what is y? Means if you differentiate a function, you get the derivative, no? If you integrate the derivative, you will get back the original point. So that's why they're counter operations of each other. Meaning, derivative of sin x is cos x. integral of cos x is sin x. One common mistake that happens is most of them will write integral of cos x also as minus sin x. If that is the case, then what should be the integral of sin x? You should ask a question. If at all you forget, no? On differentiating which function will I get sin x? Derivative of sin is cos. Derivative of cos is sin, but with a negative sign. So you get minus cos x. So that is why integral of sin is minus cos and the integral of cos is sin. Is that clear? Now, I want to add one more point here. If you see the integrals that you have added, integral that you have put, those are without limits. So whenever you do something without limits, you remember you should always add a constant. For indefinite integrals, you should always add a constant. You should write it as plus c. If you ask me why is it so, because if I have y is equal to sin x, derivative of y is equal to sin x is cos x. Y is equal to sin x plus 1. Derivative of y is equal to sin x plus 1 is also cos x only. Because derivative of sin x is cos x. What is the derivative of constant? 0. So that is the reason why you add a plus c whenever you do indefinite integration. Right? So make a note till this point. Video. Yeah. So y is equal to, if at all you have x square. Okay, I didn't tell you the equation. So y is equal to x power n is there. Okay. Then dy by dx, you can write it as, it will be x power n plus 1 divided by n plus 1 plus c. Similarly, y is equal to, I'm sorry. Integral of x power n dx is x power n plus 1. So y is equal to sin x is there. Integral of sin x dx is minus cos x plus c. Y is equal to cos x is there. Integral of cos x dx will be sin x plus c. Is this point clear? Okay. So when will you add plus c? When you do indefinite integrals. So C is added when you do indefinite integration. Okay. Now the next point is you have definite integrals. No. So when you write something like this, integral of a to b, if you write f of x dx, then let's say the output is coming out as capital F of x. Actually, I'm sorry, I'll write the reverse. Integral of a to b capital F of x, you will get, let's say you're getting the output as small f of x. Then what you need to do is you need to put the square bracket and write the limits at the right end. When you do this, you can write this value as f of b minus f of a, where this a is called as the lower limit and b is called as the upper limit. So what you do is you read it as f of upper limit minus f of lower limit. Is this point clear? I'll just do an example and show. Integral of x squared dx between 0 to 1 is x cubed by 3. Why did I write x cubed by 3? Because x power n plus 1 divided by n plus 1. So between the points 0 and 1. So substitute the upper limit 1 by 3 minus substitute the lower limit in the place of x 0 by 3. You get a number. So whenever you do indefinite integration of a function, you get a function. Indefinite integration of a function will give you a function. Definite integration of a function will give you a number. It will only give you a number. And this number indicates it is the area made by f of x with x-axis. Meaning, in the first I drew a diagram, right? This diagram. When you apply the limits, it is this area that you are finding. Integral of a to b f of x. Is that point clear? So this is how it works. Every function. Anything you want to check it, just for your satisfaction, I'll show that part, then you can copy it. Tell me some function. Something. You want sin x, sir? That's the simplest graph. You're able to see? So that's the graph for sin x. You want to have sin x plus cos square x. Sin x plus, for example, cos 2x. You want to write. It's taking some time to load. You're able to see that graph, but you need some experience to draw it, but any function will have a graph. So the sin x plus cos 2x is one function. That function is the sum of sin x and cos 2x. So when you combine both the graphs, you'll get this kind of a shape. So this is how it works. You're able to see, all these things you learn, that e power 2ix, everything, you learn it in your math in 4th chapter called complex numbers. These kind of graphs, little bit of it, sin x, cos x, those graphs you learn it in 3rd chapter called trigonometric functions. So next chapter you will have functions, otherwise the graph still will be. So it depends, okay? This is how it works. So coming back to the concept, you can just make a note of it. So now we understood now why you're doing definite integrals. If someone asks you, you can tell it. Why do we do? Why do we do definite integrals? The answer is there in front of you. To find the area made by f of x with the x-axis. So you want to copy this, no? Right. Done? So that's all for today's class. So revise all these concepts and come. So tomorrow, practice units and measurements. All those things. Whatever I taught, I asked. I want to test only the mathematical. Okay, so I'm telling you before. Those things, the problems that we did, no, something similar. Okay. Shall we wind up? You're copying. So this 1/3 is there, no? It is actually called 1/3 square units. It can be meter square, centimeter square, whatever it is, because it is area. Clear? Shall we end this?
Thank you, sir.
Yeah.